need, what I feel is uh, we need to put some more effort on the calculative part. Okay. And second is you should have confidence in yourself. See how you can start up, what if you're doing wrong? Then also, na, you do not, confuse yourself. You have to try on that part, because after doing the wrong, when you will do the correct answer, you will be able to judge yourself. Keep at this place, I was wrong. So, answers go wrong in the calculative part. But when you know the concepts very nicely, na, then gradually you will overcome this also. So while doing the paper, you analyze yourself. Ki I need to clear up with the concept and do the practice sessions, which you will do with me too, wherein you will improve yourself on the calculative part. Okay. So two strategies we will be following. Conceptual, I will be teaching you. You will be learning very nicely, because conceptual needs learning. Okay, you have to learn. Ratta not rattification. Learning with understanding. And secondly, you have to do the calculative part. How you will do the calculative part you will do with me also. Calculations, you have to improvise. You have to polish yourself on this. So if you will do these two things simultaneously, then you can very easily break your NEET exam. Okay. So that way we would be moving. Okay. Now let's do a quick revision for first 5 minutes of the topic that we have studied. And I hope you always practice those questions. Okay. Yeah, tell me now.
Yeah, just 1 second. Teacher, in the last topic, I guess we had done the models of atom first.
Yes. Yeah.
Yes. Okay. So you had explained how J.J. Thomson had made the first detailed model of an atom, how he called it the plum pudding model due to the structure of the atom as per its diagram. He
Yeah.
proposed that an atom consists of a uniform sphere of positive charge, in which the electrons are scattered all over the place. Then there was one limitation. Mass of the atoms is considered to be evenly spread over that atom, which was later proved wrong. And it then you explained Rutherford's alpha scattering experiment, where he had bombarded high-speed alpha particles on a golden foil. Then you had explained the angular deflection uh, of this experiment through its observations, which were that most of the alpha particles uh, they they passed through the small golden foil without any deviation. Then uh, some of them had some of them got deflected by small angles by the golden foil due to the angular deflection, and very very few of them got deflected entirely or by large angles.
Yes.
Yeah.
Yes.
Right. Then
Fine.
yeah,
What now you have to tell me most important two topics, the limitations and the disadvantages.
and then of the Rutherfords.
Yeah,
Right.
yeah, yeah.
Uh, One limitation was that did not obey the Maxwell theory of electrodynamic charge.
Huh?
Right. Then, which was the other point that you had asked?
What happened? What was the limitation? Limitation of alpha particle scattering experiment.
Yes, yes. The atom should have been in the continuous spectrum, but in reality, the discontinuous spectrum is observed.
Hmm. Then
No, teacher, I have not written a limitation other than this.
okay. See limitation and what is the limitation of alpha particle scattering experiment?
That is what I just told. Did you want me to tell of the other experiment as well?
Mm, in relation to the spectrum.
In relation to the spectrum, no, that's what I told. It should, according to the alpha scattering experiment, uh, the it should have been in the continuous spectrum. The revolution of the
Yeah,
electron around
yeah,
this, but in
yeah,
reality, it was a discontinuous spectrum. As
yeah.
due to the energy, it would have, if it was according to the alpha scattering experiment, it would have its loop would have reduced and it would have collided with the nucleus.
Okay, yeah. So today I'm sharing with you starting the isotopes, isobars, isodiffers, isosters. Have they taught in Akash this?
So
And isoelectronic. Now this
and
isoelectronic and isodiffers, they are very important question. I hope you must be knowing the isotopes, right?
yes, isotopes and isobars we have been taught.
Yeah. Yeah.
Isodiffers and isoelectronic also we've been taught. Isosters is new.
Okay, fine. So isotopes, actually, this name was given by Soddy. And when the different atoms of the same elements, which have similar atomic number, they have what? They have similar atomic number, but they have different mass number. So what we call them as? We call them as isotopes. So the chemical properties are controlled how? The chemical properties are controlled by number of electrons. Okay. So thus isotopes of an element, they show same chemical behavior, but different physical properties. Should I rub?
Sir, I'm on the last point.
Okay, fine. And Neil, you now work on your writing part also. Okay, you have to increase your speed slowly, beta. Okay,
Okay.
work on that part also, because I have many students, those who are super fast express. It means that you have to don't write is that this that. I'll tell you, put it in the form of notes. I'm a teacher, so I have to give you this. Okay, so for your understanding, for your learning, I have to give you this. But you have to improvise yourself on the note making also. See, so they are controlled by electrons. So thus we can say what? Isotopes are what? Isotopes, they have same chemical behavior, number one, but they have different physical properties. Okay. Now supposing I have one H1, then two H1, then three H1. Then I have Cl 17 and 35. Then Cl 17 and 37. Then next is carbon. Carbon is how much? 12 and 6, 13 and 6, 14 and 6. So what are you seeing? You're seeing the atomic number being same. Even oxygen has different. And 8, 18 and 8. Got it? So in isotopes, we are seeing the different chemical properties. So properties, they are totally depend upon the properties are number of electrons. So you will find, since the mass number is different, therefore different physical properties. Done?
Yes, teacher, done.
Now we'll see next, that is isobars. Now the name isobars was given by Aston. And so these are different atoms of different elements. Isobars are what? Isobars are different atoms of different elements. Now, which have similar mass number but different
Atomic
atomic
number.
number. So therefore, isobars, they do not show no same chemical properties. Are you getting? Because they have different number of electrons. Actually, they have the same mass number. They are two different elements. What are those elements? You can write down. Carbon is 14, 6. You have nitrogen also 14 and 7. Then you have chlorine, 37 and 17. Then you have arsenic, 37 and 18. Then you have selenium, which is 76 and 2. Cerium, and then you have selenium, which is 74 and 34. Then you have iron. Iron is how much? 58 and 6. What is the atomic number of iron? Do you know atomic number of iron?
No, no.
26. Okay. Nickel is 58 and 27. Cerium is how much, 32. Okay.
Okay. Okay.
This way you will find the difference. Okay. Now
Okay, but
third we will
teacher,
see. Yeah, written.
No, no, I didn't understand how to write it because everything is going diagonal.
7. First, second, chlorine 37, 17. See the atomic mass. जिसका atomic mass same है वो लिखना है ना. Madam.
Yes, teacher, done.
Okay. Now we'll see about isotones. What are isotones? The atoms of different element which have the same number of neutrons. For example, potassium is 39 and 19. Calcium is 40 and 20. Now tell me the number of protons, electrons, and neutrons in both of this and compare, and then tell me isotopes.
Yeah, teacher. Protons, electrons, and neutrons in potassium with
Yes, neutron is?
electrons and protons will be the same. So 19 and 19 in
And
potassium.
neutrons.
Neutrons will uh, neutrons will just be 39.
Why?
Wait, sorry.
Huh.
Just 1 second. I'll write it down. Number of neutrons will be 38 because protons plus electrons is equal to the neutron, right?
No, you forgot. How will you calculate protons, electrons, and neutrons? See, atomic mass is what? Proton plus neutron. And number of proton is equal to number of electrons. Now find out.
There the protons and electrons will be 19 and the neutrons will be 20. 39 minus 19.
So in both of them, what you will find? The number of neutrons.
Number of neutrons will be 20, right?
Hmm.
For potassium. And
20,
then for
20. Yeah. Yeah. So you are forgetting. Hmm.
calcium is 40 and 20. So the number of protons and electrons will be 20 each. And then uh,
Neutrons will be neutrons in this case will be 40 minus 20. That is 20.
yeah, that's what is.
Yeah. Now next is isodiphers. Now what are isodiphers? Isodiphers are the atoms of different elements which have the same difference of the number of neutrons and protons. Okay.
Oh,
Now I'm giving you this. Now this is your neat question. Boron 11 5, carbon 12 6, nitrogen 15 7, and oxygen 17 8. Now tell me the nitrogen, the proton, electron, and neutron in each.
yeah, it's in boron, number of protons and electrons will be 5 and number of neutrons will be 6. Then in carbon, number of protons and electrons will be 6 each. And the,
Hmm.
what?
Yeah, continue.
And number of neutrons will be 6 since 12 minus 6 is equal to 6. Then in nitrogen, it will be protons 7, electrons 7, and neutrons 8. And in oxygen, it will be protons 8, electrons 8, and neutrons will be 9.
Yes. So now tell me the real difference.
As in, I didn't understand.
You have to tell me this, no? The number of neutrons and protons, the same difference. Tell me that, no? What is the difference? N minus P in each.
N
You
minus
have to,
P
yeah.
for boron, it will be 1 since 6 minus 5. In carbon, it will be 0 since 6 minus
Ah.
6. In nitrogen, it will be 1 since 8
Now
minus
we
6.
have to find, listen, we have to find the difference between neutrons and protons.
Yes,
So
this is
what
what I'm
you're
saying.
saying means no. So do you think carbon exists?
Yes,
Because
it
the
exists.
difference in the case of boron, what is N minus P? In case of boron, what is N minus P?
And minus P will be 1 in boron.
In carbon,
Carbon, it would be 0 because the number of neutrons is 6 in that, and number of protons and electrons is 6 each. So neutrons minus protons will be 6 minus 6, so 0.
0. So how it fits into isodifer?
It does not.
So here,
Uh,
so how we will do? Here we will take 13. This isotope of carbon will be used. Because 13 minus 6 is how much?
1.
Here
1,
we
1.
have to, then it will be 1, right? So you have to
Yes.
check. Now nitrogen, tell me.
For nitrogen also it will be 1, 8 minus 7, and here also it will be 1 because 9 minus 8.
Yes. So have you understood that in the
Yes.
case of isodifers, it should be how much? It should be, the difference should be 1. Okay. Now, this is the way how you will differ. Now we'll say isosters. Now, what are isosters? Write down. The molecules, are you getting, Neil?
Yes, yes, teacher, I'm good.
Which have number of atoms and electrons the same. Done?
Yes, teacher.
Now I'm giving you two example, carbon dioxide and N2O. Show me that.
Teacher, could you just do one example because I've not been taught this topic in Akash.
So, but here I have given you now which have number
Yes,
of
yes.
atoms and electrons the same. So tell me number
Okay.
of atoms present in carbon dioxide and the number of electrons which are present in carbon dioxide. How many what is the total number of electrons in this and what is the total number of electrons in this and the total number of atoms and the total number of atoms in both.
Uh,
In both number of electrons, in both total atoms should be same and in both number
yes.
of electrons should be same. Yes.
Total number of electrons in carbon will be 6 as shown in the previous question. So we'll have to take 6C so we can balance the amount of atoms and the number of electrons.
Hmm.
Then
So tell me,
for
what is the total number of atoms in carbon dioxide?
total number of atoms in carbon dioxide is 3 because
Yes,
one
very
C
good.
atom and
Very good.
two O atoms.
Yes, simple. And in the case of N2O,
The case of N2, there will be 1, 2, 3 again.
yeah. And in the case of now total number of electrons,
Now, total number of electrons 22 for carbon.
very good, Neil. Very good. Superb. And in N2O, it
For
is
N2O, in
calculate.
16 because N has 5 valence electrons, oxygen has
7.
6. Huh?
You have to calculate total number of electrons. So how many electrons are present in nitrogen? 7.
7.
So 7 into 2
15,
plus
8, right?
yes, 8.
Plus 8 is again 22.
हाँ थोड़ा स्लो हुआ लेकिन परफेक्ट हुआ देखा अब ना इसकी मैं तुम्हारा इसी का वेट कर रही थी मैं ये आंसर बता देती है मतलब नहीं है ना by getting how finely divided work you have to do everything you have to जैसे इसमें गलती हो गई so you have to work on that you know it but you have to work on that okay so that it becomes bit fast okay
Yes,
should I
yes.
wrap
No, I'll just copy down the question. Okay. Sure.
okay it is not question
I
it is a
remember, I
topic
remember. I remember
right
actually.
now
Yeah, it is done.
yes have you done
Yes.
okay chalo let's see next one that is isoelectric species isoelectronic. Now we can say atoms, ions, molecules having similar number of electrons. For example, H2O and NH3. चलो निकालो इसके अंदर क्लोराइड आयन एंड आर्सेनिक B3N3H6 एंड C6H6 चलो सबके अंदर में कितने इलेक्ट्रॉन्स है वो निकाल के दो फास्ट then I'll be presenting you with the NEET question PYQ of NEET चलिए
Yeah, it is done. B3 and 3.
Hello, happy birthday. Thank you, thank you. Tell me what is happy about standard. The sole purpose of marriage is for
Teacher, I did for P3N3H6 and C6H6. Both of them will have 30 electrons. Yeah, teacher.
Done, Neil?
Yes, teacher, done.
Tell me.
So
It should be right.
P3 and
Neil,
H6.
it should be right. It should be correct. देख लेना. I want correct. बोलो.
Okay.
H2O is.
Can we start from the bottom? P3N3H6.
अरे वाह. चलो बोलो.
So that I got it as 30 for both of them. Then
No. हाँ चलो ठीक है. ये बोलो.
so for
ये.
fluoride ion and argon, I got
हाँ.
18.
हाँ. Correct.
And for the H2O and NH3, I got 10 electrons each.
Each. Perfect. ये गलत है बेटा. फिर से कर. Do it again.
P3 and 3H6. I took the
ये.
valence electrons, that's why. So
हाँ तो करो ना. उसमें भी तो वैलेंस इलेक्ट्रॉन ही लोगे. बाकी सब में इलेक्ट्रॉन्स कैसे लिए?
बाकी सब में वैसे ही लिया था, वैलेंस इलेक्ट्रॉन से ही.
करेक्ट तो देखो ना इसके अंदर.
Okay.
C6 है ना. चेक करो
Yes.
फिर से.
क्यों ना यार, काम है, मार्केट चालू है अभी फिर हम
Yeah, teacher, I'm getting confused because I'm getting the B3 and 3H6 one as 36 and C6 H6 as 42.
हाँ, तो ये भी तो ही होगा। करो। बोरॉन कितना आता है?
बोरॉन का 3 टाइम्स 3 किया तो 9 आता है। ये उसका फिर उसके बाद N3 का 21 आया और H6 का 6 आया।
बोरॉन का 3 होता है कि 5 होता है? तुम वैलेंस ले रहे हो। वैलेंस लेना है इसमें।
ऐसे ही किया था बाकी के इसमें भी।
भाई, कार्बन का तुमने कितना लिया है?
कार्बन का 6 टाइम्स 6 इक्वल टू 36 लिया है।
हाँ, तो 6 टाइम 6 क्यों लिया है? 6 इलेक्ट्रॉन है या वैलेंस इलेक्ट्रॉन है? इसका वैलेंस 2 4 है। तुमने किसी में वैलेंस ले लिया, किसी में कॉमन ले लिया भाई। रॉन्ग। 5 into 3 होगा। नाइट्रोजन
ओके।
का कितना लिया है? 5 लिया है कि 7 लिया है?
और नाइट्रोजन में 7 लिया है मैंने। आई थिंक मिक्स तो गड़बड़ है।
गड़बड़ ये लिया है तुमने, यहाँ पे ना वैलेंस ले लिया है।
ओके, वापस कर।
ध्यानम ध्यानम। Be2 plus, ये PyQ है। Be2 plus is isoelectronic with first Mg2 plus, second Na1 plus, 3 Li1 plus, and 4 H1 plus.
Will be isoelectronic with Li plus, क्योंकि दोनों का नंबर ऑफ इलेक्ट्रॉन्स 2 रहेगा।
हाँ, ठीक है। ठीक। ये AIPMT 2014 का क्वेश्चन था।
ओके।
रब कर दो।
ओके सो
Should I give you another question now?
श्योर
NEET
सर।
2020. NEET 2020.
यस मैम सर।
Now, next question is the number of the number of protons, neutrons, and electrons in lutetium is 71 and 175. R. Tell me.
Teacher, just for clarification, 175, its position is changed in this one, so it's still the same, right? Or different?
I have given you this. Now you have to tell me that the number of protons, neutrons, and electrons. That is a different question. Leave that question.
So the number of protons and electrons are the same. So both of them should be 71. And the number of neutrons will be 175 minus 71. So it will be 104.
I have placed in order. You tell me in that order.
Okay, so protons 71, neutrons 104, electrons 71.
Okay. So 71, 104, 71. Okay, fine. Now next, this is AIPMT question. Okay. And isotope of germanium, that is 76 and 32, is, tell me now.
No, teacher, I don't know.
Why? Okay. So if I say and isotone, then an isotone of germanium is,
No, teacher, I don't know. Isotope I didn't know because I didn't know
isotone.
the order of.
Isotone. What is
Yeah, yeah,
isotone?
isotone is the different elements which have the same number of neutrons.
हाँ तो बताओ ना, same number of neutrons. Okay, चलो, I will give option. GE 7732, second arsenic 7733, third selenium 7734, and fourth scandium 77 and 36. अब बताओ. First, second, third, and fourth. कौन सा है इसमें? जल्दी बताओ. AIPMT का क्वेश्चन है ये.
It will be arsenic 7733.
Why? Why arsenic?
Was because that is the closest. To-
Isotone means what?
Isotope means the different elements which have the same number of neutrons. So 76
So
minus
it has to be same. It should not be it should not be near to. It should be same. What is the number of neutrons in the case of this germanium?
germanium, 76 minus 32 is
Uh, 44.
44. And then 77 minus 33 will also be 44. So it will be the second option.
So don't say near to. It has to be totally similar. Are you getting? अब इसके अंदर में
Yes.
isoelectronic species है ना. It is most important. See, now we will come to our next topic, relative abundance. Now, what do you mean by relative abundance? See, isotopes of an element they occur in different percentage in nature, which is termed as relative abundance. So using this relative abundance, we can calculate the average atomic mass of the element. Okay, like we can say chlorine is 35 and chlorine 37. So what we will say, 75% it has got abundance. How much abundance? This is having 75% abundance and this is having 25% abundance. So therefore, the one which is having maximum abundance, we are actually using that in our calculations. Getting?
Getting.
Okay. Now, do you know anything about wave? Should I rub?
Yes, teacher.
Wave. What is wave? Now we are coming to the important topics.
Oh,
Should I increase the speed?
sure, teacher.
Okay, fine. So, a wave motion is a mean of transfer of energy from one point to another without any conveying of matter between the points. Means there is just the transfer of energy. Okay. So what happens when you throw a piece of stone particle on the water surface? You see what? You see different circles. So even when we put a piece of cork on the surface of this water, what do we observe? See, actually the cork is doing what? Cork is just moving up and down, up and down, up and down as the wave passes. But this cork does not travel with wave, right? The cork
Right.
remains at its place. The cork does not travel along with the wave. So we mean there is a transfer of energy from one point to another. But matter is not affected. Cork is what? Cork is matter, right? This
Right.
matter has got no affection. It is only the energy which is passing. So energy means what? The kinetic energy of the wave. So you can say the kinetic energy of the wave is moving up and down, is allowing the cork to move up and down without getting it moved. It is only the energy that is passing. So with each passing wave, with each passing kinetic energy of the wave, it is just making the cork move up and down. Therefore, they use fishing nets. They go deep into the ocean and they throw nets. So those nets, they remain at their place. It is only the water which is moving. The kinetic energy of the particle which is moving. Are you getting?
I'm getting.
Yeah. So we'll draw the diagram here. So this is what? Up, down, up, down. So this upper part here, these are the two crests. These are called as crest. And this is called as trough, the lower depression. Or if it comes down, so what is this? This is trough. And this is what? This is the direction of propagation. Okay. So this is lambda. So the distance between two crests, the distance between two trough, it is what? It is the wavelength. Okay, Neil. Neil, I hope you have understood today's class and please go through this again.
Yes, teacher.
Okay?
Yes, of course.
Chalo. Bye.
Bye, teacher.